Now, in writing this article, I mostly based on the constraint of law of physics to illustrate the enigmatic time variable as the origin of creating our physical space. That's our universe. Physical reality is existed with time and supported by the laws of science. Virtual reality is created without the constraint of time and not supported by the laws of physics. One of the most enigmatic variables in root of science must be time. So what is time? Time is a variable, not a substance. It has no mass, no weight, no coordinates, no origin. It cannot be detected or even being seen. It only can move forward and cannot move backward. Yet time is an everlasting existed, and everything associated with time has a life which includes our universe. When one is dealing with science, time is one of the most intriguing variables which cannot be simply ignored. Strictly speaking, all the laws of physics as well the physical substances could not be existed without the existence of time. Energy is a physical quantity that governs the existence of substances. Every substance was created by energy, and every substance is capable of converting back to energy. Energy and substance are exchangeable, and mass can be treated as an energy reservoir. Our universe is compactly filled with mass and energy. Nonetheless, without the existence of time, the trading between mass and energy could not have happened. Now take energy, Einstein energy equation as given by, and m is the raised mass, c is the velocity of light. Since all the laws of science in reality are approximations, I have intentionally used approximation sign. Strictly speaking, should be even written in this form. The energy generated mass should be, in practice, should be smaller than this quantity. And I guess all of you know about it. Maybe more than 3/4 of population of the world know about this equation. But what's that mean? Not necessarily everybody understands it. In view of the energy equation, it takes time to convert mass into energy. Therefore, without the inclusion of time variable, the conversion would not get started. In fact, Einstein energy equation is representation of a total amount of energy to be converted from a raised mass. In other words, every mass has the energy storage capacity as given by the Einstein equation. By incorporating the time variable in it, the equation can be represented by a partial differential form as given by. And maybe the first time I've seen that using this partial differential form using Einstein's equation. One of the important aspects about Einstein equations is that energy and mass can be traded so that the rate of energy creation from mass can be written in terms of radiant energy as given by. This is it's not derived, this is a presentation developed from point concept, and this represents divergence of energy factor, and this could be represented by energy vector, expanding it, in which we see that energy or radiant energy diverges from mass as mass decreases with time. Similarly, the creation of mass from energy can also be written in this form. The differences between these two equations is one is divergent operation, the other one is convergent operator. But anyway, let's just give this detailed discussion about these second equations. In our physical world, every matter is a substance. The reason is that they were all created by means of energy and mass. In fact, the fact is that our physical space or our universe is fully packed with substances, with no absolute empty space in it. Nonetheless, all physical substances are existed with time, and no physical substance can be existed forever or existed without time, which include our universe. Therefore, every physical substance is a temporal space. In other words, without time, there would be no substance and no universe. On the other hand, time cannot be existed without the existence of substance. Therefore, time and substance must be mutually coexisted or inclusively existed. Therefore, we see that time and substance has to be simultaneously existed. It cannot be existed by itself without the others. Nonetheless, if our universe has to be existed with time, then our universe will be eventually get old and die. Indeed, our universe will die. So the essence of time may not be as simple as we have done. For species live in a far distant galaxy moves closer to the speed of light, their time goes somewhat slower relative to ours. Therefore, we see that time may not be the same at different subspecies, for example, at the age of our universe. Since substance were created by energy and time has to be also simultaneously existed. As we know that every conversion, either mass to energy or energy to mass, cannot be started without the ignition by time. Therefore, time and substance has to be simultaneously coexisted. In other words, every physical substance, including our universe, is coexisted with time, which can be described by time-space representation. Okay. Absolute empty space cannot be existed in physical reality. Every physical space needed to be completely filled with substances, which include our universe and left no absolute empty packages in it. In reality, mass or energy are existed with time. Without the existence of time, there will be no mass, no energy, and no universe, in which we see that every physical substance is coexisted with time. Since a physical space cannot be embedded within an absolute empty space, then our universe must be embedded in a more complex physical space, which remains to be found. If we accept that our universe is embedded in a more complex space, then our space has to be a bounded or a bounded subspace. It is, however, our aim within the laws of science to investigate the enigmatic time as existed within our universe. Go back to the Einstein energy equation, for example, can be written in differential form, and I always say that this represent divergent or convergent energy operations. If you're talking about creation, that is divergent operation, that's positive sign. Yeah. The beauty about this equation is that the essence of this equation shows that the transformation from dimensionless quantity to dimension representation. Implicitly speaking, from this equation we see that all the physical substances were created by energy and time, or simply every physical substance is created by substances. In short, we can see that this is a representation from divergence of the energy vector become a time-space function. So this equation has some unique feature about it. I developed this equation to show that from point concept emerged to become a time and space representation. Yeah. That's how our universe created. A creative learner look at an equation is not just a piece of mathematical formula. It is symbolic representation. It could be a description, a language, a picture, a video. Okay, and it's precisely what I say that, one of the most intriguing questions in our life must be existence of time. There is a question: if time does not exist, then how do we know? There's a physical space. Then it must have a profound connection between time and space. In other words, if there is no time, then there will be no space. A physical space is in fact a temporal space, as in contrast a virtual space. Temporal space is a space that is described by time, while virtual space is an imaginary space without the constraint of time. In other words, every temporal space is supported by the laws of science, while virtual space may not. For example, like a television display image, similar like this slide, is a typical example of trading time for space. Any TV display image, dy dx, just exactly like this slide, takes a section of time to display it. Since time is a forward-moving variable, it cannot be traded back at the expense of space. In other words, it is the time that determines the physical space. It is not the physical space that brings back the amount of time that has been used. And it is the size or dimension of the space that determines the amount of time to create it. Based on current laws of science, speed of light is the limit. Since every physical space is created by substance, that's mass and energy, each physical space can be described by the speed of light. The dimension of the physical space is determined by the speed of light, and this space is filled with substances, that is mass and energy. So why light speed is limited? It is because our universe, a gigantic physical space, is filled with substances that causes the time delay of the electromagnetic propagation. If there are physical substances travel beyond the speed of light, which remain to be found, then their velocities will also be limited, since our universe is compacted with substances. In principle, substance can travel within a space without any time delay, if and only if the space is an absolutely empty or timeless space. However, absolutely empty space cannot be existed in practice, since every physical space, that is our universe, has to be fully filled with substances and left no empty space in it, in which we know that timeless space is not a temporal space, and it does not exist in our temporal space. It may be interesting to note that our current universe composed about 70% dark energy, maybe 20% dark matters, and the rest of the physical substance actually only about 5%. Since dark matters are in the mass form, although contribute only 20%, but dominate the entire universe energy reservation over 95% based on the Einstein's equations, energy equation. If we accepted the Big Bang theory for our universe creation first, then the creation has to be started from Einstein's energy equation as given by, because this is a point concept, and this represents a time-space function, time-space representation, and M represents a gigantic energy reservoir. It is apparently that the creation is ignited by time. I said that without time it would not happen. And the exploded debris started to spread out in all directions like a balloon. The boundary, that's the radius of the sphere of our universe, expand at the speed of light, as created debris dispersed. And it took about 16 billion light years of chaotic evolution to come up with the present forms of constellations, and our universe is still expanding at speed of light beyond current observation. With reference to the current Hubble Space Telescope observation, we see galaxies about 15 light years still moving away from us. This tells us the creation process of our universe is not stopping yet. At the same time, the universe might have been started to recreate itself since the Big Bang started, due to the intense convergent gravitational force from the newly created debris of mass, that is, galaxy, dark matter, and others. Now, let me talk about trading time in space. Let us now take one of the simplest connections between temporal space and time. All of us know about distance equal to velocity times time, okay? Now, this equation may be one of the most unique representations in connecting between time and space. As for three-dimensional Euclidean physical space can be described by this equation. And then it is trivial if we substitute the velocity vector in terms of the speed of light, can be written in a form like that, okay? Yeah. Once again, we see that time can be traded for space. Why space cannot be traded back for time? Since time is a forward variable, in other words, once time is expensed, cannot get it back. And it is more, however, more appropriate to write the space coordinate in a spherical form, in which we use the radius, the radius of the boundary equal to the speed of light times time. And we see that the edge of the boundary of our universe is expanding at the speed of light, as shown in the next slide. So essentially, it's like that from a Big Bang, and then our universe continue growing bigger and bigger and bigger. So, yeah. So again, I said that time, if we treated time as a dimension, then we have a problem. Time is not a dimension. Time is a variable. And this is a composite diagram I drew it, and then you can see that the boundary is, the boundary continue expanding at the speed of light. Yeah, and R equal to CR. Okay. Now let me conclude that we have more time to ask the questions. We have shown that time is an arithmetic variable in our universe. Without time, there will be no matter, no energy, no space, and no life. We have shown that energy and mass can be traded, in which we see that mass can be considered as an energy reservoir. We have also shown that a physical space cannot be embedded in the empty space, and the physical space cannot have any absolute empty space in it. And in other words, every physical space has to be fully packed with substances, that is energy and mass. Since any physical space cannot be embedded in an absolute empty space, it is reasonable to assume that our universe is a subspace within a more complex space which remains to be found. We have also shown that it takes time to create physical space, and the physical space cannot bring back the time that have been used for the creation. Since all the physical space are created by time and substances, this implies that origin of our cosmos is created by time with a gigantic energy explosion, in which we see that every substance is existed with time. In other words, without the time ignition, the creation would not have taken place. Although time ignited the creation of our universe, yet it is the physical substances presented to us the existence of time, in which we have concluded that our universe is a temporal space, and it is the expanding based on our current observation. And we have seen that our universe is not reaching to her half-life yet, as we accepted the Big Bang theory of creation. We are not alone. With almost absolute certainty, someday we may find a right planet once upon a time had harbored a civilization for a twinkle period of lifetime. I also have a couple of remarks to share with you. One of the most important is like that science is a law of approximation. In mathematics, is an axiom of absolute certainty. Using exact mathematics to evaluate an exact science is not guarantee its solution existed within our temporal universe. The important aspect about our temporal space is like that one cannot get something from nothing. There's always a price to pay. Every piece of temporal subspace or every bit of information takes energy and time to create. Any science that proven existed within our temporal space is physically real. Otherwise, it's a fictitious unless it can be repeated by the experiment. I'm not trying to sell, just I have upgraded my book, this is my second edition, just published about a few months ago. I think I give Professor Su a copy. I want to share to you about another aspect about burden of proof. I guess all of us know about it in mathematics. The burden of proof of a mathematical postulation must be the existence of a solution. In vividly, I remember I used to know about exactly what it is, but I've forgotten. there was a famous French mathematician called Henri Poincaré. He is a postulation. It has been proven existed the solution, but nobody can get it. Until a few years ago, accordingly, there was a Russian mathematician who done it. Yeah. And second burden is to find a solution. However, in science, we never have that kind of criteria. So this could be a very good criteria, science criterion, this temporal space. First burden is to prove in a new emerged science is existed with our temporal universe. Nevertheless, if it existed, the second burden is that can we afford to pay for it or not? Because as I already said that in our temporal universe, it's not free. Everything there's a price to pay. That's energy and time, or energy and time, or probably the entropy. Okay. Just give you a simple example, like this piece of facial tissue. That's simple. If you want really to create this facial tissue, probably it need about maybe half an atomic bomb energy dropped in Nagasaki after World War II. But not enough yet. You also need a piece of information, intelligent information. So even a simple piece of facial tissue like that, I can guarantee that only human in this planet Earth can make it. Nobody can make it. Yeah. So we are living in a temporal universe. Everything is not free. Yeah. Okay. I guess all of you know about this gentleman. He died some few months ago. I wrote my article. It's nothing to do with him. I was personally curious about it. And indeed, I actually sent my paper for him to look at it, but he was so busy, and his associate emailed back, said that he do not have time to read it. And I also emailed to the physics department in Cambridge, in England, and the very gracious for the department head to responded back, said it's a very interesting topic, but not within the physics department. So introduced me to contact the astronomy or astrophysics department. However, I cannot find the department head's name in England, and I sent my email, and they may respond back to me. If they responded back to me, I'll be delighted to go to Professor Hawkins' department to give this talk. And of course, unfortunately, Professor Hawkins died a few weeks ago. I guess all of you know about it. Professor Hawkins is a big, giant in astrophysics, and Professor Yu is a small stone. And however, Professor Hawkins is a genius. I'm not a genius. And if you keep a look at it, I think my universe is a little bit somewhat different from Professor Hawkins. Yeah. And I would be grateful and delighted if any one of you can ask some question. Anything you can ask, like time traveling, even religious science. Okay. Thank you so much. Yeah. Professor Xisang, yes.
Andre, a few years ago, a Nobel Prize was given to the physicist for the contribution. The universe expansion is accelerating. What does that mean?
What?
Universe expansion accelerating.
It's accelerating.
Yeah. It's this universe because using this law of physics. When you're expanding it, it's a lot of energy. Energy travels at the speed of light.
Yeah, I mean, you say expansion in the limit of speed of light.
Yes, the boundary.
Yeah. But you said universe expansion accelerating.
Okay, I never read his article. I said that mine is quite different. I also heard, maybe surely he died, said accidentally. He claimed the Big Bang is exploded from an empty space. It cannot, from my point of view, I'm not saying I'm right or wrong. He's a genius, I cannot argue with him. Cannot be have empty space. Empty space, even by law of physics, the velocity of light will be infinitely large. You cannot do that. So that's exactly, we concluded outside this boundary, there's another substance. How big it is, we don't know. Yeah. And if we based on Big Bang theory, we come up with this idea, from a point concept, develop this equation to describe as a time-space representation. Yeah.
So you still saying universal expansion limited by speed of light.
The boundary is by speed of light, using the current law of physics and rule of time. Unless someday, if somebody able to find out some substances travel beyond the speed of light, and that will change some of the laws of physics. Yeah. But based on the current our knowledge, about the Einstein's equation and then the law of physics, and I think it's a very interesting model. But the model is not already complete. The beauty about an article is incomplete, so people can follow up to look into it. But important about those articles, at least from my point of view, to set up a criteria. Because if you look at internet, right now there are many fictitious science emerges, claim that existed. Even talking about quantum entanglement. Okay. And then give you some example. Even if we assume quantum entanglement, it will work. For example, if I want to come to see Professor Lin, I send from the United States, I send a picture. I'm quite sure in 1 second you will get it. Okay? If I want to come to see you, you give me 12 hours. I think I can make it. But you want to come to see you, you know what I mean? In 1 second, the question is how much energy you have to pay. Because our temporal universe, nothing can be free. Yeah. You're talking about a huge amount of energy. In other words, if you're talking about the Monkey King's kind of a science, very, very frightening, you can immediately divide it into 10 Francis Yu. Why we want to develop 5 Francis Yu, we can divide it, create 10 Einstein, right? Yeah. So this is the kind of thing, not just only that, a lot of this kind of science has become fictitious. And I can say that first, if we prove the science emerges, the science, newly science developed, existed in our temporal space. It existed, but not necessarily guaranteed we can get it. Just exactly like the AI we're talking about. Within current technology, if we want to use electronics to do it, very unlikely we will create an AI as smart as Professor Su. Yeah. Very difficult. Unless we opted to go into biological science, because we have biological science, yeah. But if we do that, seems like evolution will take thousands, millions of years to develop AI, biological AI like we are. Yeah. Thank you for your comment. Yeah.
In the space, the galaxy is expanding now.
What? 不是整个 universe.
Yes.
When we're dealing in astronomy or astrophysics, mostly based on observation, not necessarily by calculation because too huge. And then by observation, we concluded the universe is expanding it. Yes. And then, so you can see that perceived. And then from that conclusion, that's why people feel origin of the universe got to come from Big Bang. And some scientists even claiming about it, someday when they collapse, will become a few inches that big. I don't believe that. I'm not saying they were right or wrong, because the one of the energy converter, conversion operator, we know that is black hole. And then the black hole could be someday bigger black hole swallow the bigger black hole up to certain condition, because black hole cannot have an energy, an infinite energy sink. So after certain condition may be exploded. So the next cycle of universe explosion, based on my model, I can guarantee that will not be happen to be at the center of our universe. Yeah. This is a conceptual, because you cannot use experiment except simulation to prove it's correct or not, because it's too big time limitation here. But again, to say that it's important at least to have certain scientific criteria. Otherwise we will become a fictitious science. Yeah, you thinking that is a science. Yeah.
所以这个整个的架构就是 based on conservation of energy.
That's right.
然后另外一个就是爱因斯坦的 energy.
That's right.
但是我看你刚刚那个 equation 就写那个电子的能量，有没有其他的能量先不要说进来？
能量，因为这个 approximation， 用电子的能量来表达它 expanding it at the speed of light， 因为很多东西在里头 ，it's not in the detail。
另外就是说，你有一个 substance 的
对
universe，
That's right。
那只要有 dark matter， 对不对？
啊，
那介中间这个 space 是不是就 empty space？
No, cannot empty space. I tell you what. When you have an empty space, first is timeless space. When you have absolute empty space, by definition of the light velocity becomes infinitely large. Give you a simple example, not necessarily equivalent. If you go down to the swimming pool, you blow a bubble. That bubble becomes bigger, bigger, and escape. If your bubble is absolutely empty in vacuum, it cannot.
那我的意思就是说，你比如说你有 top space， 左边是正的，右边是负的质量，那中间不就是？但是就是说，以我们这个很难去 define 这个 space。
The space you also can do that. Not only using that. You want to draw a boundary. You cannot draw a boundary with a substance space with empty space.
应该没有 define.
Yeah, you cannot exist it. Yeah, 这个是主要的原因。而且你从这 energy explosion 这 equation 来解释就是 everything got to be filled with substances. You cannot have empty subspaces. Yeah. 所以很奥妙的。而且刚才你讲的 very good. If you look into second law of thermodynamics, one of the most intriguing law in science, right? We accepted a subspace, entropy got to be continue increasing. But since we are in this universe, your subspace got to be a subspace of this temporal universe. And then because of energy degradation, influence the entropy. Okay? Much easier to convince people this second law of equation. I'm not changing the second law of law. Second law is too powerful. But more precisely written can be revised.
所以第三个那个就是建立在这个 entropy 这个概念，就给这个时间一个 direction。对。
而且你想一切，我现在在想，因为我不是搞这行的。Why our time has to be 1 second, 2 seconds, 3 seconds? Why cannot be faster or slower? 很可能和我们 creation of 这个 universe speed of light 有关系。That's the limit, Why? You need to understand why time got to be 1 second, 1 second. Why cannot be faster or shorter? Yeah, could be 有关系。Yeah. From my point of view, could be very revolutionary. Right now, we know more about communication limitation. 比如说，我们现在大家用的就是用这个 digital, right? And although you already know why you use digital, right? 再问一下，为什么用 digital? Digital 是最笨的方法嘛 ，right? 好像我们 use penny， 人家是很容易，right? 那每次买菜的话，我们带500 penny rather than like $5, right? 是最笨的，但是为什么用它 ？Why we using digital? And again, in the universe, everything there's a price to pay. Give you another example. Not too long ago, maybe about 10 years ago or 12 years ago, 里面有个 cassette， 你记得吗 ？cassette， 所以你一个 music， 为了省钱，我抄到最后一来 noisy。Why？ 现在 DVD 你抄了。CD 超了1000片了 ，doesn't matter。最重要 number one 的条件就是 noise immunity, because it can be repeated. But again, everything has a price to pay, right? So what's the price you pay for it? 假如我是用声音来讲你 communicate 有没有好处 比如说我从 A 到 Z， 我告诉 B， 你马上 B 的还给你01101，right？ 太长了，是不是 ？So who paid the price for us？ 谁帮我们这个代价 pay out the price for us？ 那为怎么样你们到 Professor Su 的这个领域来呢 ？Right？ 光嘛，光的速度太快了。Although every bit maybe just 像个小车能够载一个人 ，OK， 所以现在非常成功。但是呢，你在这个领域里头到说话啊，有一个 area very 好像fully attached。实际上我们做过几个 experiment 体会到，我们从前那 too long ago we talk about optical information processing, complex amplitude processing. We talk about holography. All of you know about it, right? We talk about synthetic aperture radar. I call it quantum limited subspace. 我们还没完全利用到。Yeah. 刚才讲的 come to the information transmission has been successfully done at this area. And within the certainty limit, people usually don't talk about certainty limit, okay? And not fully exploited yet. This talk will show that information transmission can actually exploit it within the certainty region, quantum limit subspace. One of the important aspects about living within our temporal universe, I already said that a while ago, one cannot get something from nothing. There's always a price to pay. Namely delta E, delta T, delta I. The question is that can we afford it? For example, a piece of facial tissue, I already said that a while ago, takes amount of energy in section of time to create it. Without the information, amount of the entropy, the creation would not have happened. Okay, 这个是 quantum mechanics 上最主要是 the connection 就是 Heisenberg uncertainty principle. Yeah, 这个 certainty principle, I don't know how many people talk about it, but could be I'm one of them talk a few times about it. Okay, yeah. 这个叫 quantum limit. Then you see the shape of the quantum unit is not important as long as bounded. Either 这两个 equation 一样 either one or the Heisenberg or the Planck's constant. 这个是它的 bounded. Okay. In principle, we see that information transmission can be carried out either outside or within the quantum limit. So uncertainty or certainty regime. However, most of the current applications I will say that in uncertainty regime, for example, like for digital information transmission, is example because primarily we're using intensity or amplitude. The basic distinction between information transmission and the uncertainty in certainty regime are one is enlarge the signal carrier bandwidth to achieve a narrower, finer resolution. 如果我们用 digital 是希望很 broadband, why want a broadband, right? 就是希望这个 delta t 越来越小，所以你能够 high information rate transmitted in time domain. 在另外一个地方再看 when you have a wider bandwidth 有什么坏处呢？ Noise， 你开了个大门，可能 noise will emerge. Okay， 所以比较了解一点。On the other hand, we reduce the carrier bandwidth delta V to obtain a larger communication subspace. 假如 delta V become very small, the delta T 就很大。比如 synthetic aperture radar, you know, I talk about thousands of, hundreds of thousand feet. 就这样 It is apparent that by minimizing the delta T in information transmission under the uncertainty regime, one would get a higher data rate transmission. Why maximize the delta T in information transmission within the certainty limit? A larger quantum limited subspace can be utilized for complex amplitude transmission. Since quantum unit regime is limited by delta E, delta T, then we see that delta E, delta T can be traded as long as it's bounded within the H or I respect. You know, 就是说用这个来解释，看你的用处在什么地方嘛。Yeah. If you like to have a quantum limit subspace bigger, then you like to use delta V 越来越小。 delta V 越小的delta T 就越大。Because in delta T 越大的 within the quantum limit subspace, you can communicate with complex amplitude. Not only to communicate, 野心更大一点呢 someday we can talk about complex computing, or quantum limited subspace computing. Yeah, 这个是 quantum unit subspace. Since every temporal subspace in our universe can be described by time, where speed of light is current as given by d equal delta t, then a subspace limited by the certainty principle represent the quantum unit or quantum unit subspace are illustrated by this diagram. Okay, it could be a Cartesian form or could be in terms of a spherical representation. 在应用方面呢，你就能够 talking about one of the important aspects about quantum limit subspace is to show that communication can be exploited within the subspace, for example, as applied to complex wavefront construction. That's holography. We have done that for many years, in which complex amplitude transmission can be reproduced for observation and processing. In light of coherent optics, we see that within the quantum limited subspace, high degree of mutual coherence can be obtained. For instance, narrower the spectral bandwidth of the electromagnetic radiator, a larger quantum limited subspace can be used for information transmission. In other words, longer mutual coherent length can be achieved for using narrow carrier bandwidth. In principle, complex amplitude communication can be, as well as computing, can be exploited within the quantum limited subspace. 主要是现在比较清楚 yeah. A complex amplitude information transmission as for the information processing can be utilized within the quantum limited subspace, unlike the conventional digital signal processing is limited by the amplitude and intensity operation. Yeah. 所以给一个另外一个观念，现在我们比较清楚了，是现在这个 communication processing 不能够 exploiting 这个 two domain. 刚才讲了就是 maximize and minimize the quantum limited subspace. Yeah. Under no noise condition, for intensity communication, we would like to minimize this. For the complex amplitude communication, we would like to maximize it because the space 越来越大。Space is our physical space, yeah. Since the size of the quantum limited subspace can be altered by trading between delta V, delta E, for example, information transmission within the quantum limit subspace, one requires a narrow signal bandwidth to enlarge the size of quantum limit subspace for communication. On the other hand, as the communication outside the quantum limit subspace, one needs to reduce the size of the quantum limit subspace, smaller. For high data rate transmission, however, broader the signal, also decrease the signal to noise ratio. I say that because you have a bigger window, then more noise intrusion will come in. To say about advantage and disadvantage. The fact is that there always will be noise perturbation in quantum information transmission, for which wider delta V is more vulnerable to noise intrusion. This is precisely the reason that we use digital transmission. As I said a while ago, digital signal can be repeated, while analog signal cannot. However, there is a price paid for using lower bit of information carrier for transmission. Nevertheless, the price paid by using electromagnetic carrier, otherwise the digital transmission would be very inefficient if one using digital acoustic transmission. Notice that every physical device has its physical constraint as imposed by the quantum limit. For example, higher frequency carrier has a wider delta V, which is more vulnerable to noise intrusion, which is somewhat lower signal to noise ratio. On the other hand, by using lower frequency carrier, it has advantage of lower channel noise intrusion due to the narrow bandwidth. It is also have a larger quantum limit subspace for limitation. 主要是讲这两个 space 呢，怎么样利用它 ？OK 呀、大家听到 quantum entanglement， 我不大清楚 about what quantum entanglement. Quantum entanglement is a physical phenomenon that occurs when pair of particles interact in such a way that quantum state of each particle cannot be independently described. even the particles are separated by a large distance. Instead, the quantum state must be described. Some scientists believe that in principle, instant quantum entanglement between particles is possible even for a large distance. In this is one of the analytical implications that have pursued the quantum scientists for decades. Distinction between entanglement and correlation, maybe there's some similarity. Entanglement is unable to release or to set free or influence. Correlation, interrelation, or coherence. In other words, two particles entangled may not have the same physical effect as their mutual coherence. For example, entanglement, distant entangle for coherence, cross-relate interaction between the particles. Distant particle entanglement is still a mystic scientific phenomenon. It needs to be physically confirmed repeatedly before it can be actually applied in practice. Theoretically speaking, instant entanglement between particles in a very large distance is possible if and only if the distance is a timeless space, timeless distance. However, in our universe, it cannot have any timeless space in it. Nevertheless, any quantum entanglement between distant particles cannot get started without the expenditure of time. Since sometimes I wonder that the so-called particle entanglement is the same physical effect or particle correlation, or to the same effect as coherence, or to the physical correlation as applied to radar imaging in detection. That's my personal opinion. However, in temporal universe, every physical effect can be represented by time and space function, in which the physical entanglement between the physical particles cannot be excluded if we assume it works. It is apparent that mutual entanglement or bilateral entangle should be or can be described by spatial and time variable representation given by. In other words, the mutual entanglement is temporal as can be existed without temporal space. And the entanglement has to be entangled within the quantum limited subspace, of which the mutual entanglement between particles can be written in a form like that. This is very similar to the coherence theory of light. 只要它真的 existed, got to be limited by the quantum limited subspace. 我个人的感觉了，这个 quantum entanglement 还是 a kind of mystery. Okay, yeah. 那这样子简单 fictitious example， 我们有4个 particle, we can define about the entangled sphere. Okay, 1 and 2 we know that we have a highly entangled, mutual entangled, and then between 1 and 3 could be less degree of entangle, and then between 1 and 4 apparently entangle is very very weak. 主要讲的是 quantum limited channel, as we have shown that information transmission within the quantum limited subspace, a narrow signal bandwidth offer a larger quantum limited subspace for communication, similar to time domain multiplexing. In principle, digital communication within the quantum limited subspace can also be done in frequency or spectral multiplex domain as depicted in this equation. 主要这个示意图我并没有多大的讲啊。So instead of looking into the time domain communication, we can looking into the spectral domain communication. One advantage about using spectral domain communication is complex amplitude communication. 是这样，这个 quantum limited subspace 啊，以我个人来讲啊，是刚刚 started, and I think let me say that we see that information transmission or inside quantum limited subspace can be exploited, for which a new era of communication will be emerged forever as the way we used to communicate. 以我个人感觉的，假如我们比较了解它的 limitation, 能够利用它 ，the whole spectral the electromagnetic spectrum 能够利用它，我相信 将来的 communication will be more efficient. And I think it's very exciting. It's very revolutionary. Okay, yeah. 这个介绍一下 We are moving into already in 21st century. We may be able to take advantage of the relativistic quantum limited subspace. Okay. 主要是说 because of relativistic time differences. 很可能in one aspect we send to the signal to the spaceship and the signal coming back or between them, we may be able to take advantage of it. Yeah, 是这样。简单讲一下，刚才讲个用 channel capacity 这个就是代表这个continuous channel, yeah. As information transmission moves to higher frequency where quantum effect takes place, the information channel should modify to a discrete model for accuracy. However, all the laws of science are approximation. Continuous model is still a very good approximation as the Gaussian distribution to replace the Poisson distribution for simplicity of evaluation, in which we see that the channel capacity is proportional to delta V and also log of the signal to noise ratio. By exploiting all the pros and cons of the quantum limited subspace, an efficient communication strategy can be developed in practice, which remains to be seen in the new era of communication. It can be okay. 刚才就给大小的这个 holography 就是 operating within the quantum limited subspace. As well, the synthetic aperture radar, the coherent length for a microwave could have been about tens of thousands of feet. Yeah. 实际上这两个 experiment 都有了，但是那个时候我们 operate 的时候，可能没想到这个 quantum limited subspace that interpret that. Yeah. Since the discovery of laser in 1960, a very narrow band visible source is available for which it enables us to develop various complex amplitude optical signal processors. For example, complex spatial filtering synthesis can be done with narrow band coherent light, of which complex spatial filter can be synthesized within the quantum limited subspace for complex amplitude processing. Yeah. 这介绍一下，就主要说 using outside, inside, they have some advantage, disadvantage. Good for amplitude, intensity communication, minimize the quantum limited subspace, wider bandwidth, higher carrier frequency, more vulnerable to channel noise and others. If you're using inside, good for complex amplitude communication, maximize the quantum limited subspace, narrower bandwidth, lower carrier frequency, less vulnerable to channel noise. Yeah. Let me conclude that we are living within the temporal subspace. One cannot get something from nothing. There's always a price to pay. DMD delta E delta T delta I. The question is that can we afford it? We have shown that a temporal subspace limited by the certainty principle represented a quantum limited subspace in which communication can be exploited within the subspace. We have also shown that information transmission can be carried out either outside or within both the quantum limited subspace. Therefore, communication can be efficiently exploited within and outside the quantum limited subspace. We have also shown that information transmission outside the quantum limited subspace is employed effectively by intensity or amplitude transmission. And the advantage of the quantum limited complex amplitude processing has not been fully exploited. We have also shown that relativistic communication in principle can be applied in practice, applied to space communication. Since the exploitation of the quantum limit subspace for communication is possible by using our ingenuity, a more efficient utilization of both sides for communication and to computing is to emerge. And that way change our information transmission and computing forever. That's my personal opinion. Yeah. 主要是这个简单介绍一下我们做比较多的事情。我个人感觉啊是 very revolutionary. You know what I mean? 因为过去我们 communication 没有注意到certain limitation. Yeah. 很简单的讲来，从 digital signal processing communication 好像是一只小飞机 能够走得很快，载一个人。那现在我们一个大飞机可能比较慢一点，可能载很多人，在每一种的 electromagnetic spectrum 的这个communication or processing 可能有好处是这样的。谢谢你们 ，OK，Thank you very much。